Hi everyone, in this video we are going to talk about the circular system of angle measurement where the unit of angle is radian. Now before we start our discussion on radian, we first need to understand how much angle we have around a point, right, which is called a complete angle by the way. So as you can see in this figure, around the intersection of the two straight lines, we have four right angles. Each of the right angle obviously 90 degree. So we have four of them. So that means the total angle around a point, the complete angle around a point would be 90 degree times 4. That would be 360 degree. So if we take a point like this, for example, right here, if we take a point like this, and then we take a ray, we draw a ray from that point, and then we rotate that ray, say suppose one complete circle. If we rotate that ray one complete circle, then we are going to get a 360 degree angle. So here the angle would be 360 degree. This is called a complete angle, right? So now that we understand that there is a 360 degree angle around a point, let's now get into the discussion of radian. Let's try to understand the definition of radian, and then from there we will learn a few more things. So let's now talk about radian, which is nothing but a unit of angle in the circular system of angle measurement. Now let's draw a circle first, and then we'll see what a radian is. So I'm going to draw a circle here. Now for this circle, let's assume that the radius is r units. So the center here, I have the center, and then I have this pink line that indicates the radius, which is r units. And then I am taking one portion of the circumference, this one little arc right here, whose length is also r. So I am taking a particular portion of the circumference whose length is also r, and if we have an arc like this arc is going to subtend an angle at the center, and the measure of that angle would be 1 radian. That's the definition of 1 radian. So 1 radian is the measure of an angle which is subtended by an arc of a circle where the arc length is equal to the radius length, meaning the length of the radius, right? So even though the arc is not a straight line, if we can somehow find out that particular portion of the arc whose length is exactly same as the radius, then this arc is going to subtend 1 radian angle at the center. So here you can see that I have the arc whose length is r, I have denoted as r. So let's assume that this arc length is also same as the radius, and then this arc is going to subtend an angle of 1 radian at the center, and let's say the center is O, right? So this is the point O. So at the center it is going to subtend 1 radian angle. I hope the definition of the radian is clear. Now let's try to understand how many radians of angle we have at the center of the circle. That means around the center, one complete angle that we know as 360 degree, we want to convert that into radian and see how many radian that would be, right? So now before we go into the maths, let's try to understand the picture here a little bit. So if we want to indicate how many radians we have around the center of the circle, if we want to indicate that pictorially, so let's try that. I'm going to now try and draw a few more radians like this. So suppose we have one more radian right here. So if I highlight this with a green color, so this could be, if this is another portion of the arc whose length is r, then that will also subtend another radian at the center. So let me do a dotted line to the center. So suppose this is going to give us one more radian right here. So I can say this is also another 1 radian right here. And then let's do another arc right here, and this arc is also going to give us another radian if the arc length is equal to the radius. And then let's draw another radian right here. Let me remove this O from here, and now let me draw the other radian here. So this white portion of the arc will also give us one more radian. Let me write it here. And let's try to find one more radian. So this blue color portion of the arc, or the blue color portion of the circumference, this little blue arc will give us one more radian there, and probably we'll be able to draw one more radian here. So let me try that. So this turquoise colored arc of the circle will give us one more radian at the center, and then we're going to be left with a little more angle right here. I'm going to indicate that with double yellow arcs here to indicate that that is the leftover angle right there, and that would be again a fraction of a radian. It's not a complete radian, it's a fraction of a radian. So as you can see, we have 1, 2, 3, 4, 5, 6. We get full 6 radians around a point and a little bit of 1 radian, right? I mean, it's not a complete 1 radian, it's just some percentage or some fraction of a radian. And now we're going to do the math and see how many radians we get around a point, right? So far we have been talking about the point which is nothing but the center of the circle. So around the center of the circle, we can easily see that we have 6 plus radians, right? We have 1, 2, 3, 4, 5, 6 and a little more. So we have 6 plus radians around the center of a circle, or you can say around a point, right? So now let's do the little math and see how we can convert from degree to radian. So let me scroll down. I should have already mentioned that the symbol of the radian is like this. So if we say 1 radian, generally it is written like this, 1, and with a very small tiny little c right there on the top right corner. So this is actually 1 radian. So this is nothing but, we can say 1, this is 1 radian, and that is the unit of measurement in the circular system of angle measurement. If you ever see like this tiny little c on the top right corner, that indicates radian. And sometimes you may not even see that tiny little c there, that would also mean radian. When you are dealing with trigonometry, it will mean radian. So sometimes the radian symbol may appear or may not appear on a question, and whether it's there or not, if it is an angle, you can assume that it's a radian. If it is a degree, obviously if it is a degree, the degree will be written like this. Suppose you want to say 1 degree, then we write it like this with a small little circle there, right? It's not a 0, but it's a small little circle. So this is like 1 degree. But for a radian, we generally indicate that with a tiny little c as in Charlie, tiny little c, or sometimes that c may be absent also. So sometimes you might even see it like this. So suppose somebody has written like, somebody talking about an angle which is like 1 radian. The person might say, hey, 1 radian, but the person may not put that little c over there. So that is also 1 radian. Now we know that are units of the circumference of this circle, right? Now let's talk about this circle. Say suppose, what is the circumference of this circle? Well, we know that if the radius of a circle is r, then the circumference of the circle would be 2 pi r. In this case, the radius of our circle is r units, so the circumference of this circle would be 2 pi r units. Now we know that the arc of length r subtends 1 radian angle at the center, right? So can we write it like this? In the unitary method, we can say it like this. So we can say r units of circumference subtends 1 radian angle at the center. Obviously this angle is this is at the center, so it subtends one radian angle at the center. And then using the unitary method, we can say, okay, then 1 unit of circumference would subtend how much angle? Let's see. So we can say 1 unit of circumference subtends 1 by r radian angle at the center, because from r we are going to 1. So in the unitary method, we can say, okay, this will be whatever angle was before, we divide that by r, then we get this comparison. And then now we want to say, okay, how much angle would be subtended by an arc of length 2 pi r? That means the entire circumference, that means the entire circle. So now we are going to find out how many radians would be subtended at the center by the entire circle, by the complete circumference, right? So now using the same unitary method, now I am going to say, okay, then 2 pi r of circumference would subtend whatever angle. So let's see that. So we can say that 2 pi r units of the circumference would subtend 1 over r multiplied by 2 pi r, so many radians, and that would be equal to, let me scroll down, this is equal to, so the r will cancel each other, this r in the denominator right here and the r in the numerator, they will cancel each other, so we'll be left with just 2 pi, so it would be 2 pi radian angle, right? So we can say, okay, this will be 2 pi radian, this will be 2 pi radian angle. That means the angle at the center of the circle is equal to 2 pi radians. So we can say, okay, if 2 pi radians is the total angle or the complete angle around a point, so we can say, okay, then 2 pi radian is equal to 360 degree. In other words, we can say, okay, then 360 degree would be equal to 2 pi radian. And going forward, I am not going to write the radian symbol anymore. So if I simply say 2 pi, please assume that we are talking about the angle radian, meaning this amount of angle is in the radian unit, right? So please assume that this is 2 pi radian. So from here we can say, okay, then 1 pi radian would be how much? If we divide both sides by 2, so from here we get 360 degree divided by 2 would be 2 pi divided by 2. and from here we can say, okay, then 180 degree, which is a straight angle, would be equal to pi radian. So 1 pi radian would be 180 degree. And then if we continue this math little more, you can see that now I'm going to again divide 180 degree by 2, meaning I'm going to divide both sides by 2. So this side will become 90 degree. 90 degree would be pi by 2 radian. And again, if we divide this by 2, that would be 45 degree. 45 degree will be equivalent to pi by 4 radian. Similarly, if we divide that 180 degree equals pi, if we divide that by 3, so from there again, if we divide that by 3, we will get 180 degree. So let me write it here, 180 degree divided by 3, that is equal to pi by 3, which means that 60 degree corresponds to pi by 3 radian. And also if we divide 180 degree by 6, so now I'm going to divide 180 degree by 6, that will be pi by 6 radian. That means this is nothing but 30 degree would be equivalent to pi by 6 radian. And those are the most common angles which are used in trigonometry. So I'm going to highlight them. That these are our most common angles that we should remember their conversion between the degree and the radian. So pi radian means 180 degree, then pi by 2 would be 90 degree, 90 degree would be pi by 2 radian, and similarly 45 degree would be pi by 4 radian, and then 60 degree would be pi by 3 radian, and 30 degree would be pi by 6 radian. Now let's do one more little math here. We know that complete angle around a point came out to be 2 pi radian. So if it is 2 pi, then how many that would be? Well, we know that the value of pi is equal to, for high school level mathematics, we can use 22 by 7, which comes out to be close to 3.14. So let's use this 3.14 value for the value of pi. So if we have complete angle as 2 pi radian, so 2 pi radian would be how many? Well, it would be 3.14 times 2, that would be equal to 6.28, so many radians. And if we look at the circle, if you look at our picture, we also got little over 6 radians here. So if you count it, we have this 1 radian right here, which is written in yellow, then another radian in green, another radian in green, so total 3, then another radian in white, that is 4, another radian in blue, that is 5, and then another radian in turquoise color, that is light green color, that is 6, plus we have a little more left over here also, so that is the 0.28 radian. So we have 6.28 radian, that makes the complete angle around a point. And that is the math that I wanted to show you right here, that 2 pi radian would be equivalent to 6.28 radians, right? So 2 pi radian means it's actually 6.28 radians. And that is nothing but the complete angle around a point, right? So this is the complete angle. I hope it is clear up to this point. Now what I'm going to do, I'm going to now find out 1 radian is equal to how many degree, right? So let's do that conversion also. Let's do that little math. I'm going to scroll down a little bit. So we know that 2 pi radian is equal to 360 degree. So all the conversion maths will begin from here. 2 pi radian is equal to 360 degree. So from here we can say, okay, then 1 radian would be 1 radian. So let me now put the radian symbol there, because we are talking about 1, right? So the 1 radian would be 360 divided by 2 pi, whatever degree that would be. And if you use the calculator, you will see that this would come out to be 29578 degree, right? And if you again convert that into degree and minute, so that would be 57 degree and 17 minutes, approximately 17 minutes and 45 seconds. So 1 radian is actually equivalent to 57 degree and 17 minutes 45 seconds approximately. So this is pretty close to 1 radian. So that is another interesting fact we should try and remember, that 1 radian is equivalent to about 57 degrees. Say roughly 57 degree. You can remember it like that. 1 radian, almost 57 degree. So now that we understand what a radian is, now let's talk about how to calculate the length of an arc that subtends a certain angle at the center of a circle. So I'm going to draw a circle again. Now let's suppose we have a circle of radius r units, and we took a small little arc from the circumference, and this arc actually subtends theta radian angle at the center of the circle. So I have indicated that with theta. Theta is the Greek letter theta. So generally in trigonometry the angles are represented by theta or even x. X is a very common variable that we use to represent angles in trigonometry, and also theta is also very common. So suppose this one little arc whose length is s units and it subtends an angle theta radian at the center. Again, I repeat, this is theta radian, this is not degree. So now we are going to talk about radian only, right? So suppose this arc subtends an angle of theta radian at the center of a circle whose radius is r. Now we want to find out the value of s in terms of r and theta. So s is actually some sort of a value involving r and theta, and let's do that little math. So I'm going to use the unitary method again. So let me write it down. So from our previous discussion, we know the total angle at the center of a circle is actually 2 pi radian, and that is subtended by the complete circumference, and the length of the circumference is 2 pi r, that we know that. So here I am saying that okay, so 2 pi radian angle is subtended by 2 pi r units of arc, where 2 pi r means is the complete circumference. So we can say it like that, right? And then using the unitary method, I'm going to say, I hope that seems accurate. So now we are saying that okay, so 1 radian angle would be subtended by 2 pi r divided by 2 pi units of arc. And now let's see, theta radian would be subtended by how much arc? So we can say that theta radian angle would be subtended by 2 pi r divided by 2 pi times theta, so many units of arc. And if we simplify this will come out to be r times theta, because as you can see, the 2 pi in the denominator and the 2 pi in the numerator, they will cancel out each other. So we'll be left with the r and the theta. This will be equal to r times theta. So now we know that the value of s. So from here we can say, okay, from here we found that the length of the arc that extends a theta radian angle at the center of a circle, the arc length is actually r times theta, where theta is in radian units. That is one thing we have to remember. It is very important. Theta is not in degree. Here theta is in radians. So we have to remember that fact, right? So the length of the arc, so this s is nothing but the length of the arc. Let me write it down here. So that is the formula of the arc length. Arc length is the product of radius times theta, but theta must be in radian, not in degree. So if theta is in radian, then the arc length would be r times theta, where theta is the angle subtended by this arc at the center of a circle, whose radius is r units. I hope everything made sense. Thank you for watching. See you in the next video.